Here we have question 1 mixed exercises. Okay, and don't let this physicsy notation affect you. Okay, if you don't take physics, that's fine. You can still do this question. It just takes off your kind of GCSE knowledge. But even then, even if you didn't know Newton's law, didn't know Force, you can still get the right answer here. Okay, so calculate the magnitude of R in newtons. All right. So what is R? R is F1 plus F2. So let's figure that out first. Okay, and whenever you do this addition, I really strongly recommend you writing F1 and F2 in terms of our column vector. Okay, I find it much easier. I don't know about you, but my I's and my J's, as I do lots and lots of workings out, I often get confused by them, and I find this way simpler to understand. Okay, so we're doing minus 3, 7 plus 1 and negative 1. Okay, and here we're just doing negative 3 plus 1 and then 7 take away 1. Okay, so R is negative 2 and 6. So the magnitude of R, what does the magnitude of R mean? Well, here's R, okay, and here is your vector. Okay, it's going across 2, back 2, kind of up by 6. Okay, and we're using Pascal's triangle to, not Pascal's, Pythagoras theorem, sorry, I said that, Pythagoras theorem to figure out what this R is. Okay, so the magnitude of R, kind of the length of R, is by Pythagoras 6 squared plus, as in you can say negative 2 here, but I thought you just do 2 squared. Okay, so this is square root 36 plus 4, which is square root 40. Okay, and then here you're finding a square root number. I'm sure you all know how to do this bit of it, and you get 2 root 10, and then your units here are newtons. Okay, perfect. That's question A. Next, calculate to the nearest degree the angle between the line of action of R and the vector J. Okay, lots of strange wording here. Line of action of R. Okay, what does all of this mean? Well, let's put B. Okay, line of action of R and the vector J. So we know what the vector J is. Okay, so let's put the vector J. And the line of action of R, it would make sense that this is R, right? Okay, and the angle between these. All right, even if you're not 100% sure what the line of action is, this is a very, very good place to start. Okay, finding the angle between these two vectors. Okay, now what more specifically is this angle? Well, we've got 2 here, 6 here. Okay, which means we have 2 here, 6 here. Okay, and now we are just using sine, cos, and tan. Okay, so we got the opposite and the adjacent, so we use tan. So tan of this angle is a third, then inverse, tan inverse of a third. Okay, which gives our x to be 18 degrees.